as geologic structures go, folds are pretty common, and generally relatively easier to identify out in the field. Folds themselves are basically caused by a number of different factors, and they involve the same thing, is that normally horizontal layers are basically bent upwards or downwards and then sort of squished together. This can occur in many different ways, usually the biggest being compression, when two forces on either side of a piece of crustal material force the material inwards, which causes buckling and folding of the layers. It is also possible that you may observe it in what we call a drop-down basin. When we have extension in the crust, what happens is that some of the material as it extends breaks off and sort of subsides or sinks downwards. And as a result, this material forms sort of a basin, and this in itself, when preserved, can actually come in the form of a fold. Now, there are several different types of folds, but the two main ones I want to talk about are synclines and anticlines, because they are the most common. Synclines have a very characteristic shape to them, generally V-shaped in cross-section, with the youngest units stacked in the middle. The other type, which is what we see here before us, is an anticline, which is more of a horseshoe shape with the oldest units closer to the center. A fold has several components. In a sense, we have right about here, which is the axis of the fold, which is the center of curvature. And then on the other ends, we have the arms or limbs of the fold. As you can clearly see, the units here start at an angle upwards, slope here, hit the joint or the center of the fold, and then bend over down in the opposite direction. Folds are very important for us because they represent periods of time where there have been important tectonic events. And in general, they can tell us that there's some sort of force that's causing deformation of these units, which can be very vital in trying to understand the geological history of an area.